Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about best, average, worst case of order of growth. In previous videos we have learned the asymptotic analysis and how to calculate the order of growth of a function. If you have not watched the previous videos, then I highly recommend to watch those videos and come back to this video and continue watching this video. So let's get started. We are given a problem, and the problem is given as find the square of a number. And we wrote a function to find the square of a number. In this function, we are doing some work constant number of time. Let's say initializing a response, returning a response. And we are doing some work linear number of time. Let's say this statement, we are running linear number of time. So let's use our knowledge of asymptotic analysis and the order of growth and calculate the order of growth of this function. What we do in asymptotic analysis, first we get the expression of the time taken by a function, right? And then we follow the direct method. The direct method says remove the constants, remove the coefficient of the higher order term, you get the order of the growth. Okay, so let's follow the same steps. So first get the expression of time taken by this function. If you see this function clearly, it would be c1 n plus c2. How we got this expression? We are doing certain operations constant number of time, let's say this one, and certain operation like this in linear number of time. So by calculating the number of operations, we get this expression c1 n plus c2. Now let's remove this constant c2. This is a lower order term, and let's remove the coefficient of higher order term. So here the higher order term is n and the coefficient of n is c1, so let's remove it. So after removing the lower order term and the coefficient of higher order term, we get the n. So we conclude that the order of growth of this function is n. So far everything is fine. So let's add some complexity in this function. In software industry, there is one thing which always remain constant, and that is a change. We get a lot of changes. So let's see, to satisfy our customer requirement, we add one extra line in this function. What this code is doing, it checks if n is divisible by 5, then immediately return 0, else do other operations. So in previous example, it was very clear for us to calculate the order of growth because we are doing some constant operation, some linear operation, and that's it. It was easy for us to calculate the order of growth. But if I ask you that tell me the order of growth of this function, then it might be difficult for you to calculate the order of growth. So this is where our best case, average case, and worst case comes into picture. So let's talk about the best case. Let's say if I pass 5 as an input to this function, then when we execute this function simply checks if n is divisible by 5 or not. And in this case, as we are passing 5, this condition becomes true and we immediately get the result as 0. Right? The remaining operations is not going to run in this scenario. So this is our best case. If I talk about the order of growth of best case, it's going to be constant. Why? Because we are immediately returning 0 if our input is divisible by 5. Now let's talk about the average case. What happens in average case? Let's say we are running this function 2 times. At first we are passing multiple of 5, and second time we are not passing multiple of 5. For example, first time we are passing 14, and next time and second time we are passing 5. So the time taken by function for the first input is going to be c1 n plus c2 because we are passing non-multiple of 5. So this is going to execute this time. And in second time we are passing 5. So this time this code is not going to work and only this code runs. And this is the constant operation. So if we sum both the times and divide by 2, we get this expression. Let's again use our knowledge of asymptotic analysis. And what we do in asymptotic analysis, we cancel out the lower order term. So here c2 by 2 is lower order term, c2 by 2 is also lower order term, c1 and 2 is also lower order term. So if we cancel out all the lower order term, we get the linear. So on an average, the order of growth of this function is linear, right? So far, best case is covered, average case is covered. Now let's talk about the worst case. we usually interested in knowing the worst case of an algorithm. Why, I will explain you in a bit. Okay, so what happens in worst case? What happens if I always pass numbers like 8, 7, 6, 4, 14, 16? So all these numbers are not the multiple of 5. So this code is never going to execute. We are always executing this part of the function. So in the worst case, the order of growth of this function is going to be also linear. And we are always interested in worst case. Let me give you an example to understand why we are interested in worst case and not in best case. See, if you have developed a software and you tell your clients that in best case it takes 1 second to open, but I don't know in worst case how much time it takes. So do you think your client buy your software? Obviously not, because you don't know what happens in the worst case. But in other case, if you tell your client that my software opens in 1 second in worst case, they become happy to hear this, that our software takes 1 second in worst case, but usually our software opens in fraction of second. So that's why we generally focus on worst case rather than best case. Now what about the average case? So we generally use worst case, but sometimes we might get interested in average case also. In some cases we want to know about the average case also. It is good to know about the average case of an algorithm and worst case of an algorithm, but best case we generally do not use in industry. So I hope now you have a clear understanding of what is the best, average and worst case of order of growth of a function. So this is it for this video. Thanks for watching. See you in the next video.